Welcome to New Breakpoint. New Breakpoint is a series for developers and by developers, and my name is Michelle Sandford, and I am the Developer Engagement Lead for Australia and New Zealand. We broadcast on the second Thursday of every month, and if you join us, you can ask questions that my guests and I will answer during the show. And of course, you can watch the episode on demand on YouTube afterwards. Today, my guests are Microsoft Cloud Solution Architect Arian and Technical Solutions Professional Rivaaj. They have built a custom AI gateway solution that simplifies scaling and securing genAI initiatives, and it's now available on GitHub for everyone to enjoy. Rivaaj, why don't you start us off by telling us what are the key challenges in scaling generative AI for enterprise use?
Thanks, Michelle. Probably a bit of context in terms of generative AI. We know that generative AI has been a game changer, primarily in terms of how we interact with genAI. We no longer need Python or R scripts. We can use natural language. But it's also ushered in a change in terms of how we develop solutions. And one of those key differences is that while we interact with genAI as a REST API, it's not your traditional REST API endpoint. It doesn't represent a single resource, but rather the prompts and completions that you receive could represent data, code, or specific behaviors. And so genAI tends to be a platform that developers can use. And what that entails is that we see a number of cross-cutting concerns start emerging. So Arian, myself, and a number of colleagues have identified a number of patterns emerge, and we've tried to capture them with the AI-Sentry implementation. So effectively helping reduce the friction for teams starting to scale and add more generative AI solutions into their environment.
Talking about cross-cutting concerns, you're talking about things like API key sharing, rate limiting, content safety, stuff like that?
Exactly, yeah. And if we think through what this would look like, teams typically start off with a initial application, generative AI application. It could be a hero use case. And you'll be thinking about how to develop it, what frameworks to use. You'll focus on prompt engineering and building out your orchestrator. And that's a great way to get started. But once you start looking at your second use case, you start seeing additional concerns come in, such as security. Like I said, genAI tends to be a platform, so we tend to share our large language models across our apps. And so we have to start thinking about security. And then we layer on our next use case and we start thinking about resource allocation. How do we keep these apps from contending for resources, as well as observability? And so those are some of the themes we see emerge as we build out these generative AI solutions. And AI-Sentry, again, is intended to capture these cross-cutting concerns and provide a default implementation so that developers can get started quickly without necessarily giving up any of the flexibility they have today when leveraging a large language model.
Yeah, I guess everyone starts building their own version of ChatGPT and hooking up all their own company data to that as their first use case. And after that, they then start to think about what else can we do with generative AI, because it's there are so many things they could be doing with it, multimodality and all of that built in, which then puts a lot more demands on the resources. What about like logging and monitoring token consumption?
Absolutely. And that's definitely one of those cross-cutting concerns that we see here. And there's quite a few we've identified. I've put up the slide here. Logging falls under our observability requirements. At the most basic level, we want to have visibility of the types of prompts and completions that are being sent. But within an enterprise environment, we start seeing additional concerns later on. One example is PII data. Conversations may include personally identifiable information, and we have to decide whether we remove that before we write them down to logs. And I think this is probably another good example of where traditionally, from a software engineering perspective, we would use Azure Monitor to log to upload our logs for the applications themselves. But one of the challenges is around who within the organization has access to those logs. And that's where we have to look at using other mechanisms. And that's where AI-Sentry provides a default mechanism to isolate logs at an application level.
So if you're going to summarize for the audience what AI-Sentry is in a nutshell, how would you describe it?
I would actually go down to a good old software development patterns. Eric Gamma and the Gang of Four had captured two broad patterns around being both a proxy and a facade. The proxy layer of AI-Sentry, which leverages APIM, and Arian will go into more detail, is really about enhancing or extending the OpenAI APIs so that they can be enhanced without necessarily requiring clients to alter how they use the Azure OpenAI REST APIs themselves. And then the second layer is around all these cross-cutting concerns. Arian will also touch on some of the OWASP recommendations. We see that teams can build that out by embedding that in each application, but the downside is that increases our marginal costs. Each team, each project has to capture these requirements and re-implement them. So we often see teams build them out as individual subsystems that client applications can call. But again, we end up with the challenge that you end up with a bit of a rat's nest of interconnection. So that's where we leverage the facade pattern so that we have APIM and the facade providing us with all of the goodness of cross-cutting concerns being automated away by presenting a very clean and unaltered REST API to our clients.
So this isn't about us building something that will force customers to use all of our solutions. It's something that can go in between and you can use it with whatever things you want to plug into it as well, right?
Exactly. And that's been the key idea here. One of the design principles we worked on is to not impose any changes to the Azure OpenAI REST APIs. So we effectively present the same Swagger spec that you would get if you were to go directly to Azure OpenAI. But what we do provide are all the implementations of the cross-cutting concerns that I mentioned to end users. So you could plug in a Jupyter notebook, you could plug in a C# app or Python app, and the integration would be exactly as if you were going directly to Azure OpenAI itself.
Cool. So this is going to help everyone with load balancing, with security, with scaling, and it's just going to make everything easier for them to do. It's a sort of organizer?
Yes, the key idea is to reduce friction. I think that's been the experience we've had at organizations, like I mentioned, start with hero use cases. And there's so much excitement that comes after that first use case that when you get to the second use case, you probably have to expend the same amount of technical effort. Whereas on the other end of the spectrum, some organizations try and build out the platform entirely and then find use cases. So you end up with a long delay between the platform starting and your first genAI solution getting to production. We try to find a middle ground here. Teams can get started really quickly and they can scale rapidly, but we don't want to impose any technical debt in terms of using custom APIs. We're presenting you a straight pass-through API with the benefits of the automation behind it.
That's really cool. And it's available on GitHub as an open source repository, which we have put in the little widget resources on the screen. So anyone can already go to that. Arian, maybe you want to show us a little bit, like walk us through each of the steps so that we can see what it looks like. Because even with these fantastic slides, it is sometimes hard to imagine how everything fits together.
Yeah, so AI-Sentry. Basically, it's a Python-based implementation that abstracts, that sits in front of the OpenAI. It can be fronted by any API gateway. In our case, obviously being a Microsoft shop, we are fronting this stuff with API Management Gateway. However, what we found out of the box with API Management Gateway is that we couldn't actually still log streaming and non-streaming. Well, non-streaming responses we could, but as soon as we went to the streaming scenario, the logging capability kind of buffered the response. So we kind of essentially downgraded to a non-streaming event. So as a result of that, we really tried hard not to kind of have to build custom code. But in the end, we had to build some of this custom code to satisfy some of the features that are needed by a lot of these enterprises in conjunction with your typical API gateway in front. So the chargeback itself, we've implemented that by logging the requests and responses. In scenarios where we don't actually have a token count coming back from the actual OpenAI API, we actually do use some libraries to calculate that on the side before we log it. Now, the logging part is all asynchronous. We've made that decision so we get out of the way of the request and response and keep the performance of the solution as high as possible, so we don't slow down any of the requests. Now, in terms of load balancing, yes, you can do lots of different load balancing options now inside API M, but we're giving you the ability to kind of extend that further than what that product provides. So the entire AI-Sentry solution is built on top of Dapper. For those that haven't seen or heard what Dapper is, it stands for Distributed Application Portable Runtime. It's been an open source project from Microsoft for probably 4 or 5 years now, and it was donated to the CNCF Foundation, Cloud Native Foundation. And essentially what Dapper provides is an abstraction layer between components, which could be different databases that you might be writing to, different logging engines that you might be pushing out logs to, open telemetry logs to, or different triggers that you might be responding to. The reason why we've used Dapper is to again, enforce further extensibility of the solution. If you need to build additional modules to do additional load balancing options, or logging options, or test evaluation options when you upgrade your models, it's all possible there. The sample code that I'll show you leverages Redis as the underlying messaging technology. And essentially, we've got a bunch of different workers that will pull messages off the queue and do their own set of processing. So for chargeback, like I said, we use logging for that. We have a logging worker, and we have a summary logging worker as well, which is a much smaller log. Instead of logging the whole request and response, we use the summary logger, for example, for dumping information so we can create dashboards around token usage per use case or per model, et cetera, et cetera. In terms of logging, we've also found that customers do want to strip out, in some scenarios, PII information that might be coming as part of the request or the response. Again, this is not something that's available out of the box inside APIM gateway. So we decided to kind of follow the same approach, using Dapper, using a worker, and then running some background PII stripping. At the moment, the PII stripping is performed through Azure's cognitive services, the text analytics service, to be more specific. But given that this is highly extensible, we are actually planning to build another version, and you can swap the two out to see whether it's a better cost structure, is to use OpenAI on its own as well. So basically have a prompt that will actually perform the PII stripping against the input of the text that comes through you. So kind of weird, AI-Sentry talking to itself just to do PII stripping. So if we go a bit further on these slides, the architecture level. So as I alluded to earlier, clients will connect through some sort of gateway before they hit our AI-Sentry layer. In our case, it is the API management layer that's in front. Now, the current deployment of AI-Sentry, it's designed to run as containers, and it's designed to run on top of Kubernetes. So we've got a deployment YAML file that basically stands up all of these components behind the scenes. You'll notice that there's a facade proxy layer. That's essentially just an API running as a separate pod. And then to the side of that pod, we've got the Dapper sidecars, which are essentially publishing out the requests and responses as they come from OpenAI onto the queue. And then once they're on the queue, we've actually got a lot of different choice for different queue technologies and responders here. In our case, our example uses Redis that we've just deployed on top of AKS as well. But we have a pretty large mining and manufacturing customer that's using this solution, and they're running it actually with RabbitMQ. So there's no problem using any of those supported messaging technologies. Now, once it's on the queue, we can actually subscribe to lots of different processes on the side there. An example here is this, Cosmos DB logger, where we'll log the information back to Cosmos. So we can do our chargeback, so we can do our test evaluation of how this these conversations would actually perform on a later model of OpenAI in the future. And then the stripping of the PII, as I said earlier, at the moment is done through the cognitive service, text analytics cognitive service in Azure. But we are building capability to kind of call OpenAI there as well and perform the same thing. Alternatively, if you didn't want to host some of these messaging services directly in AKS, and you wanted to let the service provider like Azure run that for you, you can swap those components out again for Service Bus in Azure or Redis on Azure as well. So the cross-charging capability we've built to support both asynchronous and synchronous calls. One of the troubles with OpenAI API is that only the asynchronous calls actually include the token usage information from the API itself, which means that if you're doing any sort of streaming events, you actually need to calculate what that token usage looks like, because the actual API doesn't know when it starts and when it ends. So it's up to the client to figure that out. We didn't want that to be another responsibility on the developer side. And instead, again, we brought that in as a bit of a functionality inside AI-Sentry. So from the synchronous side, we basically just go into a loop and we wait until that the streaming termination occurs. And then we take that whole payload and actually calculate the token usage and then chuck that across into our persistence layer, which in this case is Cosmos. Now, the general logging, as I said earlier, we had the requirement that maybe some chatbots need PII stripping enabled. Some of them might have it completely complete logging, so they don't care if PII information is in there. And again, that's something that we provided as part of AI-Sentry. So the way this works is AI-Sentry is expecting some common HTTP headers, and you can see on the slides here, we've got a consumer header, we've got a log level header, and then those headers then can have different settings applied. Now, with those options enabled, this will allow us to go and log beyond the 8,192 byte limit that currently exists when we try to use APIM. So we can go well beyond that, as far as the persistent technology supports on the back end. So we've implemented the ability to load balance what we refer to as smart load balancing. And essentially what we do is we keep track of the remaining request tokens across all the different pay-as-you-go OpenAI instances. We keep that in memory currently within AI-Sentry. We keep it as a hash table. And we basically sort on the highest remaining requests. And basically every request goes through this evaluation process, and it really tries to exhaust or at least load balance across the least busiest instances or the most powerful instances first. So that actually reduces the potential to run into some sort of rate limiting problems. Of course, if there is a rate limiting issue, we will also not try to run away from that. We will actually send that across back to the client, because ultimately the client should be responsible on how they deal with, 500s and 429s and that type of stuff. On top of that, we can also prioritize certain instances to be the more heavily hit ones, avoiding the remaining requests tokens. And then we can also make it really simple and just round robin, in which case you might actually run into more 429s with that particular style. So again, talking about this smart load balancing across multiple pay-as-you-go instances, we've got a concept inside AI-Sentry called a backend pool. And essentially, a backend pool can have one or more OpenAI instances. And we've actually stitched it all up based on a naming convention. So if you notice here, there might be a client here called HR chatbot and a finance chatbot. Each of them might use a different backend pool. In this instance, they're both using the same. So they're both going to be fighting for resources in there. Now, based on that naming convention, the backend pool inside our configuration of AI-Sentry can then reference multiple pay-as-you-go instances. And then the idea here is, and this is where people setting this up will need to ensure that the right sort of models and the right sort of rate limits on those models exist across all those instances. Otherwise, if you don't have the right models and you've kind of specified them in this configuration, we will blindly just, either round robin or do that smart load balancing, as I referred to earlier, across those instances. But if you don't have the same equivalent models, you will get different behaviors coming back or potentially errors. So that's why, we've got this slide here just to kind of make sure that when you do deploy these things, the pool needs to have instances with the same model capabilities deployed. Now, one of the big things that we've seen with our customers is, they build this chatbot, they run with it, but the actual OpenAI APIs are changing really frequently. And it's not good enough to, what you built 6 months ago doesn't guarantee that API is going to be supported for much longer, right? So that puts pressure on the development team to constantly update their code. What we wanted to, and that's the right thing to do, developers should always be updating their code to meet the latest stuff. But in the event where you might be stuck, or maybe the developers left the organization, or they're simply too busy on other projects and they can't update the SDKs on their side of things, we wanted to build some backwards compatibility support using adapters. So what we've done is we've provided the ability, even if the client doesn't change its SDK and it's now outdated, and let's say the latest APIs are 2024-02, but the code is now still thinking that it's talking to this particular API, the shape, let's say the schema has completely changed between there. What we can do is we can hijack that request, and AI-Sentry has the ability to kind of go and modify HTTP headers, body, request query strings, and the methods as well. So basically, we can go and change that whole shape to match the shape of the latest API, and we can define all that stuff in our little adapter without having to change anything here. So again, this is a bit of an anti-pattern. We don't recommend that you do this, but we've done this in case that you run into these problems, which we've seen some customers already starting to run into. Another thing is it might not be a breaking change on the API, but you might be going from, let's say, GPT-4 to another version of GPT-4. And maybe it's now trained on more billions of parameters, and you need to understand what the impact of that model change is actually going to be back to the client. So what we can do there is, because we are logging all the requests and responses into our Cosmos DB, we can set up a little what we refer to here as a model test evaluation harness. And essentially what we do is we can sample 10% of the logs and run them through as if we're another chatbot, and then write those results out and then compare the difference using some sort of framework behind the scenes to see have the results actually improved, or actually have the responses degraded as part of this model upgrade. And the beauty there is that we can actually then provide confidence with this test evaluation harness without actually changing all the users to the latest model. So we can kind of go and split, 10% go to the newest model and 90% go to the more stable model that we're already used to. But we sample the 10%, we test it out here, we compare the difference, and then, if we get the confidence that that's actually looking good, we can start decreasing this number here and increasing this number here. So that kind of gives us a bit of a, your sort of DevOps loop.
Can I ask Arian, is that evaluation stuff part of the AI-Sentry, or it's something that you're reaching to through it?
No, so that's completely left up to the consumers, what they use. Our particular customers, there are some frameworks already out there that Microsoft's published some guidance on, so they can just plug into those.
Right, I see. So all of these things are just different things that you can plug in via the Sentry. Okay, cool.
Exactly. And again, Michelle, I think this is to that principle around we didn't want to impose frameworks on teams, but certainly, if teams are using AI Studio, we've got Azure Open AI with prompt flow evaluations, a really great way to get started. But again, the AI-Sentry leaves it open to teams to adopt the frameworks they need to complete the evaluation.
Yeah, I was getting excited because all of the content safety and evaluation and monitoring and stuff that we have in AI Studio is really one of my favorite things. And so, yeah, I wanted to know whether that was something that we were replacing or something that we are now just connecting to via the AI-Sentry. Cool.
Yeah. In terms of the setup, I did allude to, this is a container-based solution, and we've made it run on AKS. By made it, I mean, we've provided some YAML files. But the idea is we will be building an equivalent that can run on Azure Container Apps as well. It's a relatively simple change. We just haven't had the spare time to do it as yet. But in terms of the AKS setup, we've got the main namespace really is this AI-Sentry namespace. In there, we've got an ingress controller, which points us to the facade, this proxy layer service. And then from that service, we've got one or more replica sets, pods that are there. It's purely up to you how many of these you define to have. In our environments, we've really got about 3, but we've seen some customers that push it out to about 10 different replicas because they're really pushing through quite a bit of load through this stuff. Now, in that same namespace, we've also got the various different workers in the background that do the processing of logs and all those other things that we just discussed. And to the side, in our setup, we're using Redis as well as our messaging technology. So we're not using Redis for caching. We're actually using it for message streams. As I said earlier, this is optional. You can plug a cloud native, Redis, Azure, Redis cache, for example, or you could go to a different technology and deploy RabbitMQ. Some of our customers have done that, or you could use RabbitMQ in another cloud, or use Service Bus natively in Azure.
Cool. Arian, can we have a look at it now? Because I am super excited to see the live demo in your GitHub repo.
Yeah, sounds good. Let's walk through, I guess, the GitHub repo, first of all, just to familiarize the viewers of what the code structure looks like, and how they can actually build these containers and how they can deploy it in the environment. So if you go to github.com/Microsoft/AI-Sentry, that will take you to the main branch of this repository. The README file, has some nice slides, some nice text around this stuff, pretty much what we talked about in the presentation. But what I do want to draw your attention to is the configuration aspect first. So the first part that you'll need to provide some infrastructure, base infrastructure. On our end, it's Cosmos and AKS. We have bicep templates to spin that up if you wanted to. So this will spin up APIM, OpenAI instance, as well as AKS clusters behind the scenes, so you can deploy AI-Sentry directly to it. You can kickstart that process by the deploy.ps1 script. Once you've got the infrastructure there, you'll need to provide some configuration to AI-Sentry. The configuration is actually provided directly to AKS as a configuration object, but the shape of that object is unique here. So what I'll do is I'll quickly explain what that shape looks like. So if you go in the README file and look at this backend configuration section, click here. This will take you to a sample JSON file. So I'll just minimize that. And what you'll notice here is we've got an array of pools. And inside that pool, we've got a lot of different endpoints. So this is where you'll go and register your like-minded OpenAI endpoints. Now, I've got some configuration here where you can set up some initial remaining requests and remaining tokens for each of those endpoints. And if you imagine, most companies will have more than one endpoint here that it will load balance against. Okay, mm-hmm. So this is important. Grabbing this JSON file, you will then go and escape that JSON string and feed that into So if we just minimize that, and if you go into your deploy folder in AKS, there is a AI-Sentry deployment file there. So this describes basically what I showed earlier, the services, the ingress controllers, as well as like the pod deployments and stateful sets. So you'll notice here, we've got the facade app. At the moment, it's just one replica. It's a stateful set, and there are some annotations in there. The first one, before we get into the Dapper stuff, is this annotation called azure.workload.identity. So essentially, for us to talk to OpenAI from our facade layer, we can either use API keys from OpenAI, completely acceptable. In that case, you actually don't need this label. But to make it more secure, what we've done is we've enabled our code to use managed identities or workload identities, as they're called inside Kubernetes.
I guess just to call out one item here is that the API key that you present to OpenAI isn't the API key that clients have to use. And I think that's a key separation we find that a lot of teams find benefit from.
Exactly. But from a cyber perspective, we also don't want to be storing API keys of OpenAI within our config. So to make it more secure, you can use modern authentication using workload identity. So that's what this label here is for. Obviously, to set up workload identity in AKS, it's quite a few more steps involved. I've got instructions also set up in the README file for that, should you go down this path. And then the other annotations that you see here are mostly to do with Dapper. Because we are using Dapper sidecars, we need to kind of communicate that to our deployment. So we provide the port number for Dapper, what the health check endpoint is, the frequency of the health check, et cetera, et cetera. Now, image itself, you'll provide, when you build your, under the build path, there are some Docker files. So you'll see that there's a Docker facade file. This file here builds the facade image, the worker image, and summary worker images. So this is basically the entire solution. You can kickstart that process by running this build AI-Sentry container script. And once that's all built and pushed out to your container registry, in your deployment file, you will make sure to reference that particular container registry so that when the containers start to load up, they can look at those references. Mm-hmm. Now, this is the configuration that I showed you earlier around pools. That escaped JSON string, we will provide as a environment variable into the facade container. So that's where we provide that. And then we've also got some additional stuff around logging level. So you can tweak that from error, info, and debug. We start off with info so we don't flood the internal facade app logs. Given, these are high throughput systems, we've optimized info to be a nice mix of, giving you still exceptions and errors.
Arian, while you're there, what are those environment variables for?
Yeah, so this is actually feeding information back into our facade app. So I showed you earlier that we have this like backend configuration file for AI-Sentry. Essentially, that file is the string. That JSON escape string is the endpoint config environment variable that you'll feed in here. This will essentially tell facade app, what the different endpoints exist for it to perform the load balancing and the actual request and response queries against. On there, we've also got the log level. We've set that to info. We've optimized it to info so that in this high throughput system, we're not flooding the logs. We just provide relevant enough information for you to still diagnose problems. But should you need to increase that, you can always increase that to debug as well. And then the last one is optional. As you can see here, it is required by the workload identity. So should you choose to use the workload identity in AKS to communicate to those OpenAI endpoints from AI-Sentry, then you will need the client ID property to also be set. All of this is well documented within our README file. The next one down is another stateful set. This time around, it's a logger, and this is the Cosmos DB logger. So this is the component that does the logging as well as the PI stripping. Very similar setup as above, But the only difference is there will probably be fewer environment variables needed. Actually, just a few little ones here. Notice that what we are looking for is, because our PII stripping capability comes from cognitive services, we are looking for that endpoint and the API key to get to that cognitive service, as well as the logging levels. And then right after that, it's another logger, and this is a summary logger. So this is what we'll be producing. Actually, I'll just show you here now. So those two loggers produce two different database outputs. The full request logs, as you see here, will show you everything. It will show you all the headers that have come through, whether streaming was enabled or disabled, who the client was, what the parameters were, what the input messages were, what the token usage looks like, as well as the response. Everything is captured there. And now if you turn on PII stripping or level on or off, this one here is complete, which means that it will actually send everything through. It will strip out PII information from here as well. Now, this is really useful for your test evaluation harness and those type of things and debugging problems. But it's probably not so useful. There's too much information here for it to be easily used by a dashboard. So for that reason, we have another logger called a summary logger. And if you look at the items inside our summary logger, it's much smaller. It's much more compressed. And it's got just the relevant information that is really needed for cross-charging and billing back, what the usage is. So see here, we can see, based on the partitioning key in Cosmos, we've decided that it's going to be month followed by the year, followed by the GPT model, and followed by the caller, the consumer. So in a real life scenario, this could be the HR chatbot consumer and how many prompts and total tokens it's consumed for that particular session. So this is really nice shape for people to then build nice dashboards so they can control that cost side of things. Cool. So following on from the summary worker, we do have several components as well that need some definitions around them. So in our case, like I said, this is completely pluggable. We've decided to use Redis as our messaging queue. And you can see here the type is pub/sub Redis. If you wanted it to be a service bus or something like that, you just swap that out for whatever is needed. Now, each of these components are the properties that are needed by these components are very much specific to the technology set. So for Redis, all that it needs is essentially, just the host name and the password. But other components like Cosmos DB, they'll actually require a bit more information, like your master key, etc., etc. So our persistence layer, as you saw, was Cosmos. So for that reason, this component is Cosmos DB. And we've essentially got two there. One is for summary, and one is for the complete logs. And that's pretty much it. After that, that's that file completed. The next step that you need to do then to fire this up is essentially, let's just load up VS Code, is just run a kubectl apply command, which I've already done. And then what you'll see is if you list out your namespaces, you'll have an AI-Sentry namespace in there. So if you do kubectl get pods AI-Sentry as the namespace, you'll find that all those components are now up and running. You'll find that also there are multiple containers behind each of them, and that's because there's a Dapper sidecar behind each one. So for Logger, we've got the actual logging codes plus the Dapper. And then for the Facade app, because we're using workload identities there, it's got a workload identity pod container. It's also got a Facade container as well as a Dapper container. Now, with all that in place, what you can do is you can then discover what your service is. So you can actually hit this thing. So we can take the external IP here. In my case, it's an external IP. You'll take the Facade app. You'll take that URL. And then underneath in your code, I've also got some tests which you can run yourself. You can use Postman, you can use whatever you like, but if you want to stick to what I've got, you can actually test this out using one of these requests. So you can just drop in that IP address as your resource name here, and you can.
I guess Arian here, you're using a VS Code extension to submit these HTTP requests.
Yeah, so this is just the REST client extension, which makes it super simple, right? I don't need to have Postman or any additional tools installed on my laptop. I can just click on that, and that should behave like Postman. There's my response, and that's come back from AI-Sentry. In this case, I've actually asked for a embedding request. We wanted to test that AI-Sentry is not breaking across any of the kind of typical use cases like completions, embeddings, vector generations, etc., etc. So you've got all those different tests inside here. But yeah, this request essentially went to my AKS cluster directly. Facade app ran this request, and then depending on what my logging options were, you can see here I've got PI stripping is enabled. It would have logged this with PI stripping into the Cosmos DB as well, behind the scenes.
Arian, there's a lot of talk about APIM around at the moment. Is there a way to integrate this with that?
Yeah, so certainly. APIM can front AI-Sentry. So what in that scenario you'll end up doing is you'll end up creating an API endpoint for your OpenAI Swagger definition. But what you'll end up doing is for the backend settings, instead of going directly to your OpenAI endpoint, you'll actually go and define the IP address or the URL of where the service is deployed that fronts AI-Sentry. Once you do that, then yeah, you can basically hit, instead of hitting AI-Sentry directly, you can go and hit your APIM endpoint, which will in turn actually hit AI-Sentry behind the scenes. And the beauty there is then you can actually use APIM for rate limiting. And then for other things, like I said, with token counting, logging, and all those PI stripping capabilities, we'll let AI-Sentry take care of that for us. So then we kind of provide the best of both.
So it's going to help us with scaling. It's going to help us with security. It's going to help us with smart load balancing. It's going to connect everything together very nicely. Can I just ask one small question? Does it add a lot of cost to their solution using this?
Yeah, look, so we're running it on AKS and Cosmos. You can swap out any of those technology sets. We find Kubernetes is a fairly consistent sort of cost, under $1,000 for a 3-node cluster, which is pretty decent. From Cosmos side, it all depends, like what the SKU that you're using and how frequently you're writing in there and if you're purging documents out.
So on a return on investment analysis, then is it that this is for large enterprises, or can everyone make a use case for this? And it's how you plug it together, like what you decide to run it on, that makes it worth your while.
Exactly. I think it's really for anyone. Anyone going beyond one use case will end up running into the problems that we described here. And I think rather than rebuilding all that from scratch, you can go and leverage the work that we've put in to produce this.
Awesome. So that's good that the two of you have done all of this to help people. Perfect. You can find all the resources for this episode on GitHub, including the link to the repository for AI-Sentry. The README file for AI-Sentry is really comprehensive, and you'll be able to go through it at a slower pace and understand all the aspects of it, which is really, really good. You can also reach out to your account teams, and your cloud solution architects will help you with that as well, if you would like. So we've been answering a lot of questions online during the episode, but I'm sure there are more. So we're going to stay around for another 10 or 15 minutes and answer those questions for you. Put those in chat now. Thanks again, Arian and Rivaaj, for this episode, and we really appreciate all your time, expertise, and passion for this subject. It's been very inspiring to see all of the work that you put into building AI-Sentry and making it so that our customers can accelerate their journey to scaling out enterprise solutions. Thanks again, Rivaaj. Arian.
Thank you.
Thanks very much, Michelle. We've really enjoyed putting this together for everyone.
Thank you all for tuning in, and we look forward to seeing you again on New Breakpoint next month.